was good. I'ma be gaming. I'm gonna play some balls. Yeah, I can't do full screen for some reason. Yeah, Bad Game is much better than Balls, to be honest.
Hi, my name's Mark. For years, I've wanted to make my very own video games using software like Unity. Unity is the powerful game engine behind titles like Cuphead, Neon White, Tunic, Outer Wilds, Hearthstone, Firewatch, and even the Pokemon Diamond remake. But I've always found that lengthy, multi-part, meandering tutorials just send me to sleep. I can't learn by watching someone else. I have to get hands-on and figure things out for myself. And so last year, I developed a solution that actually works. It's a 3-step technique where you, 1, just learn the absolute basics of Unity, then 2, cement those lessons with simple exercises, and then 3, figure out the rest as you go along. And it totally worked. In the space of about a year, I went from ripping off iPhone games to working on my very own puzzle platformer about magnets. And I released an interactive video essay that's had over 100,000 plays. But wait, I hear you say, how do you do step 1? How do you learn the basics when the software is so complicated to figure out? Well, for me, it was about writing down a list of things I would need to know regardless of what game I was going to make. Things like how to make a character appear and move them around the screen, how to make stuff spawn in and then delete it again later, how to have collisions and game over and animations and sound effects. Then I learnt all that by hunting through lengthy tutorials, reading the Unity docs, googling esoteric words, and doing a lot of trial and error. And so the whole point of this video is to save you that hassle. This video is the tutorial I wish I had when I was learning Unity. So in the next 40 minutes, we're going to use the engine to make Flappy Bird. Not because we want to make Flappy Bird, but because in order to remake this addictive iPhone game, we'll need to learn basically everything I just listed, from spawning objects to getting game overs. This tutorial will cover every step of the way, from downloading Unity to understanding the UI to writing your very first line of programming code to building a game that you can share with your friends. And then when the tutorial is over, I'll share some concrete next steps that you can take in order to continue learning the rest by yourself. Sound good? Then let's get started. Okay, let's start by getting Unity from the website. In step 1, we're going to become familiar, which in most games will be a level. Voila, we have graphics. That will, of course, show up in the 4th and final panel, A quick recap. Unity has 4 panels by default. Project holds all the stuff in our game. Hierarchy lists all the game objects in the current level. Inspector lets us see and change those game objects, and we can see the level in the scene view. And a game object is an invisible container that we can fill with components like a sprite renderer. In step 2, we're going to use more components to make the bird into a physics object that is affected by gravity. And then we're going to write some programming code to make the bird fly up when we press the spacebar. So let's add another component to like sprites, sound effects, scripts, tiles, fonts, and so on. Some of this stuff will be made in Unity as we go along, but we can also just drag and drop files from elsewhere on our computer. Like, I've made some sprites for the bird and the pipe in Photoshop, and I'm going to import them into my project like so. I'd recommend you make your own, that's always more fun, but if you have zero artistic ability, then check the description for these assets. Here is the project panel. This will contain everything that is the default screen layout. Here is the projects and so on. Some of this stuff will be made in Unity as we go along, but we can also just drag and drop files from elsewhere on our computer. Like, I've made some sprites for the bird and the pipe in Photoshop, and I'm going to import them into my project like so. I'd recommend you make your own, that's always more fun, but if you have zero artistic ability, then check the description for these assets. The next panel is the hierarchy. This contains all of the stuff that's in the current scene, which in most games will be a level. We're going to start by making the bird, so right click and choose Create Empty. This has made an empty game object. So what's that? Well, a game object is essentially an invisible container. It has a position in space, a rotation, and a scale. Then you can fill that container with components to add extra features. For example, if we add a sprite renderer component, we can slap the bird image onto the game object. Absolutely everything in our level will be a game object with components. The bird, the pipes, even the user interface, and the camera. All of this magic happens in the third panel, the inspector, which is for messing with game objects. So once we've selected our new empty game object, we can put a name in the top field. Let's call it bird. And we can see and change the game object's position, rotation, and scale under transform. We can now press add component, pick rendering, and pick sprite renderer. To make this work, we need to fill in
Rendering sprite render. Got it. Then we just gotta wait for this to load. While that loads, I'ma just go to the toilet and also brush my teeth. Yo, CCC, Desmos. Yo, how's your day going? My day's going good, thank you, bro. How about you? I'll be right back. I'm just gonna go to the toilet while this loads. I'm back. Oops, what did I just do? Uh-oh.
Game objects. So
Okay, there we go. Alright, so,
once we've selected
yeah,
our
I'm back. What's good? So,
new empty game object, we can put a name in the top field. Let's call it bird. And we can see and change the game, and if you want, you can use. Here we can see what's in our current scene, and this work, we need to fill in the sprite field and pick sprite renderer.
Okay. So first, I'm going to, because I'm trying to learn how to like actually code in Unity. You know what I mean? Like, not just, you know, copying ChatGPT, just straight up stealing other people's codes from tutorials and stuff. I want to actually learn how to code. So, yeah. That's what I'm trying to do right now. It's a bit hard, but I'll get used to it, I guess. I guess I'll have to. There we go. Yeah. Stick that in there. Great, now. Create empty bird, he said. Component, he said sprite renderer.
To make this work, we need to fill in the sprite field. So just drag the bird image from the project panel into the field, and voila, we have graphics. That will, of course, show up in the fourth and final panel, the scene view. Here we can see what's in our current scene, and if you want, you can use these tools to move stuff around, scale it, and so on. This section has an extra tab for game view, which shows us what the game will look like from the main camera when it's running. Also, from this drop-down, we can set a resolution or aspect ratio to get a better idea of what it will look like when played. So I'm going to choose 1920 by 1080. Oof, the bird takes up way too much space. We could scale it down, but let's actually just zoom out the camera. Like I said before, the camera itself is a game object in the hierarchy, and it has a camera component with stats we can mess with. By changing the size, we can zoom out. I'm also going to change the background color. Lovely. We can.
Ooh, how do you do that? Oh, that's cool. I never even knew that. I'm gonna make it like. Yep, that's nice.
Now press the play button up here to start the world's most boring game. Okay, let's make it a bit more exciting.
Bet.
A quick recap. Unity has 4 panels by default. Project. In step 2, we're going to use more components to make the bird into a physics object that is affected by gravity. And then we're going to write some programming code to make the bird fly up when we press the spacebar. So let's add another component to our bird, a rigid body 2D. This turns our bird.
Alright. This is where we're getting into the good stuff. A rigid. Oopsie, I keep writing stuff wrong, I swear. And let's see what he does.
Into a physics object with gravity. So when we hit play, the bird drops and falls off the screen. Cool. We'll also want this bird to be able to interact with other objects. So let's add a collider, a circle collider 2D. Back in scene view, we can see the collider as a green outline. It's a bit off-center for me, so I'll use the offset to move it. Act with other objects. So let's add a collider, a circle collider 2D. Back in scene view, we can see the collider as a green outline.
Yep, he has gizmos on. There we go.
line. It's a bit off-center for me, so I'll use the offset to move it. And a little game design trick. If we make the collider a bit smaller than the image, it will let the player get through the pipes even if they just touched the edge.
Ooh, that's cool. Me like that. There we go. I'd say that's good. I bet.
It gives the game a bit of leniency and makes it feel more fair. The final thing to add right now, a script. This essentially lets us make our own custom component, but we'll have to write it ourselves using programming code. Choose New Script from the components list and call it Bird Script. Once it's loaded, double-click the script field to open it up. This will open the file in Visual Studio, which we installed earlier. So, welcome to programming. It's not too scary, promise, we'll take it slow. We're writing in C#, that's the programming language, and the only thing to worry about right now is these two chunks here, start and update. Start is for any code that will run as soon as the script is enabled, and it runs precisely once. Update runs constantly while the script is enabled, and it will fire off every line of code, every single frame, over and over and over again. So the main thing we're going to be doing with code right now is, well, if we go back to Unity, see these numbers and text fields in the components and how we can change them in the Unity editor? We're just going to write code to change these stats while the game is running. Just as a dumb example, and we'll delete this in a second, in start we can type GameObject. That refers to this bit up here.
Let me just do this.
And then a dot. You'll see a list appear, and many of the items refer to stuff back in the inspector, like isStatic, tag, layer, and name. So let's pick name, then write an equal sign, and in quotes, give our bird a name. Finally, we must always use a semicolon to mark the end of a command. And we must always save the
It's weird, bro. Scripting is weird. What are all these signs for? Why can't scripting just be like this? Make bird fly, and then it just makes the bird fly. Why can't it be like that, bro?
script before we go back to Unity. Now, when we run the game, the name of the game object has been changed. Nice.
Let me see. If this works, I'm gonna be the most successful scripter out there. Let's see. Bird. Now it should be Bob Bird. Yeah! Science! Ooh, programming. Damn.
Nice.
Crazy.
Okay, delete that code, that was just for sillies, but it shows us how we can use code to talk to the game.
just for
We can
sillies.
write a command by choosing someone to talk to, in this case, the game object. and then a topic of conversation, its name, and then a command. Change it to Bob Buddington. We'll be doing this a lot. So what we actually want to do is, in the Rigid Body 2D's component, under Info, we'll see a grayed out field for velocity, and we want to write some code to add upward velocity to the bird to make it fly into the air. The problem is, initially, a script can only talk to the GameObject's top bit and the transform. Right now, this script is completely unaware of the other components, so we need to sort that out first. We need to make a special slot on this script for a Rigid Body 2D, so we can then talk to it and send it commands. This is called a reference. We're going to create the reference up here, between the class name and the start function. We're going to write public
and I'm gonna delete this silly thing. It was just for sillies, I swear.
Rigid Body 2D, my rigid body. So we now have a slot to store a rigid body.
Got to do this. Yeah, there we go.
2D. And we have a name that we can refer to make sure we're talking about this specific Rigid Body 2D. And because we made it public, it means we can access this slot from outside the script. So if we save and go back to Unity, we'll see that the script component now has a field for a Rigid Body 2D. We can drag the component into that slot and voila.
W's, bro. Let's just see if this works. This guy is so W. He explains things in so much detail. Damn. Alright. Ooh. Uh-oh. I accidentally put, a silly whoopee here. Now, let's see. Come on. Yeah! W's in the chat! I'm a pro scripter now. You know me. They call me the pro scripter for a reason, buddy. Yeah.
We have established a line of communication between the script and the rigid body. Okay, back in Visual Studio. In Update, we can type my rigid body, then dot. And now look at all the things we can talk about. Angular drag, gravity scale, mass. These are all properties on the component. The one we want is velocity. We want to set this to a new number. And so just like before with the name, we'll write an equals. Now what we're actually writing here is a vector, which is two numbers to represent a position in 2D space. And in this case, it's used to represent a direction for the bird to travel. We want the bird to go straight up, so 0, 1 would be a good one. I'm going to use vector2.up, which is a built-in shorthand for 0, 1. And to give it a bit more power, I'm going to multiply that vector by a number, say 10.
Hmm. That's multiplying now, apparently. Apparently. And Unity is just like that, because, you know, Unity. Bro, is it? I just did it wrong. Bro, it was me.
Which should send the bird flying up in the sky. Now, like I said before, any code in update will run over and over again every frame. So if we save the script and hit play in Unity, off goes our bird. Bye! That's not what we want. We want this to only happen when the player hits the spacebar. So it's time to use the most fundamental bit of programming code, the if statement. An if statement is like a gate. You can surround some code with a fence, and every frame that code will be completely ignored, unless the game meets some specific conditions that are written on the gate, in which case the gate is open and the code is read and executed. So we want to say, if the player...
Nah, bro, imagine getting executed. That's great. Imagine being a code that gets executed. Yes, it works! Man, scripting is actually fun when you understand it. I don't hate scripting, bro. This is fun.
hits the spacebar, then add upward velocity. To do this, we can write if, and then in brackets we can write the condition. This time we're not talking to a component, we're talking to Unity itself, specifically its input system. So we'll write input dot. Then we can pick get key down, and in brackets, keycode dot space.
That's not that hard.
This asks Unity
Ew, little oopsies. Space, not something. So
if the spacebar has been pressed on this frame, and then we'll finish with equals equals true. A quick note on equal signs. We use 1 to make the thing on the left be the same as the thing on the right. And we use 2 if we're just checking if the thing on the left is the same as the thing on the right. Cool? Anyway, so this code says, if the spacebar has just been pressed, then, and then we'll use curly brackets. These are the fence in our analogy, and put the flap code in here. So now...
Alright. This guy is very, very smart. Very, very smart. But I want the sideways version of this. Give me that. Control C, Control V. We don't want no spices. We don't want no spices. Oh, no. That could be bad for the code. I don't really know, but just in case. Because we ain't sure.
In update, every frame the game
I could just delete this.
will go to the gate and be asked, "Hey, has the spacebar just been pressed?" If yes, the code will fire and the bird will flap. If not, it will skip the code in the curly brackets and try again next frame. So, save the script and go back to Unity. We can now hit play and, ta-da, the bird goes up when...
Ain't no way. Bro, if this works... Like, if this works and I didn't know coding was this easy. I mean, it's still not the easiest, like, make bird fly. Okay. Yeah, right when I say it's almost easy. What do you mean that's invalid? That is not invalid. It's the curly bracket the man told me about. It's not invalid, you poo-poo pee-pee. What's invalid? That's not invalid. You're invalid. Whoa. I did something wrong. That's the thing. That's the thing. That's the thing. That's the thing. That looks about right. Kinda. Let's just hope it works. Ooh, yes, one thingy now. Error. I don't know. Is that the problem? Did I just fix it? Nope. That's sad. Me not to know how to do it. Me not to know how to fix it. Bro, I'm so confused.
code will fire and the bird will flap. If not, it will skip the code in the curly brackets and try again next frame.
He told me to add equals true. Did he just lie, bro? Okay, now it should work. Bro, it doesn't work. Oh my god. Bro.
So, save the script and go back to Unity. We can now hit play and, ta-da, like a gate. You can surround some code with a fence, and every frame that code will be completely ignored, unless the game meets some specific conditions that are written on the gate, in which case the gate is open and the code is read and executed. So we want to say, if the player hits the spacebar, then add upward velocity. To do this, we can write if, and then in brackets we can write the condition. This time we're not talking to a component, we're talking to Unity itself, specifically its input system. So we'll write input dot. Then we can pick get key down, and in brackets, keycode dot reference to the rigid body. Let's make a public float called flap strength. A float is right, stop, change the number. Has the spacebar just been pressed? If yes, the code will fire and the bird will, then we'll finish with equals true. A quick note on equal signs. We use 1 to make the thing on the left be the same as the thing on the right. And we use 2 if we're just checking if the thing on the left is the same as the thing on the right.
There we go, I just fixed it.
Cool.
Oh my god, I put an unnecessary curly bracket. Okay. That's on me, but yeah. Now. Yo! Wait. Yo! It's literally like jumping when I press space. Yo, that's crazy though. Actually, they're scripting. Bro, like it actually works though. It like works, bro. Damn. Yo, what's good Froggy and Ducky VR? What's good Remix VR? What's up everyone? What's up? Alright,
anyway, so this code says if the spacebar has just been pressed, then, and then we'll use curly brackets. These are the fence in our analogy, and put the flap code in here. So now in update, every frame the game will go to the gate and be asked, hey, has the spacebar just been pressed? If yes, the code will fire and the bird will flap. If not, it will skip the code in the curly brackets and try again next frame. So, save the script and go back to Unity. We can now hit play and, ta-da, the bird goes up when we press space. We have now created a character and made it react to input. This is a video game. Hooray! However, it feels like trash. The flap isn't right and it doesn't feel like the original iPhone game. So we could change this number, save, open Unity, run the game, not quite right, stop, change the number, save, but that's slow and dumb. Let's do something smarter. First, we're going to make a variable. Let's go back to the top of the script and under our reference to the rigid body, let's make a public float called flap.
Okay. Open up the script again. Yeah. Okay, and then now that that's here under public rigid body. Okay, under that he said public float flap
strength. A float is a floating point number, basically a number that can have a decimal place. And then back in our update code, we'll multiply the vector2.up by flap strength instead of 10. Now, back in Unity, you'll see that the script component has a new field, flap strength, and we can change that whenever we want to make the game feel different.
Great.
We could even change it during the game, but note that anything you change while the game is running won't save when you press stop. This means you can play with values to your heart's content without worrying about screwing up your game. So, if we mess with the flap strength and also the gravity scale on the rigid body, we'll hopefully get to something that feels good.
Okay. 4.5 gravity scale, he said. Yeah, I want to make it like that. And this he just made 12. Alright, now let's test this. Let's see if this is any better than before. Just want to see. Yeah, I think this is better. Gravity is way too strong though, that's the thing. I'll make this 3. Now let me test. Great. Yep, this is way better. Good.
Changing numbers back and forth. Honey, that's game design. Recap time. We can use code to change the properties of a component while the game is running. A script cannot talk. Okay, so the secret to Flappy Bird is that while it looks like a bird is flapping along through a world of pipes, it's actually not. The bird stays completely still, and it's the pipes that move across the screen. So in step 3, we're going to make pipes spawn into the world, move across the screen, and then delete themselves. We'll start by making the object we want to spawn. This will be 2 pipes which move across the screen from left to right. Let's make another game object called pipe. Put it exactly on the bird for now to get the sizing right. And then we'll make another object within this one called top pipe. This is a child of the first game object's parent. This way we can nest multiple game objects and move all of them at once just by moving the parent. So let's repeat what we did for the bird. Add a sprite renderer for the pipe image.
Oh yeah, this. Ready for the top pipe? Yeah. Sprite renderer. There. That one. Great. None.
And add a collider, a box collider 2D this time. We don't need a rigid body because it's not going to be affected by physics.
Okay. Box collider 2D. Go.
We can then move it up above the bird, but keep the X position as 0.
I'm gonna rotate this, rotate this upside down. So it's actually a top pipe. Now that looks way better. Yeah, that's not correct. There we go. That's way better. And now...
Finally, we can duplicate this whole top pipe object, call it bottom pipe, and flip it upside down by changing the
Yep. Got it. Oops, I probably should have just copied that.
Y scale to -1. Then move it down.
Ooh, Y scale. Not position. Oopsies. Oh yeah, that's good, that's good, that's good. That's fire.
below the bird. As you can see, if we mess with the pipe parent game object, both pipes move, scale and rotate along with it, with the parent as the pivot point. So let's add a script to this parent's object to make it move across the screen. We'll start by creating a variable for move speed. If we give it a number,
big float. I'll just do public float move speed 5.
here it will fill this as the default value in Unity, but we can always change it there later. Then we'll write code to move the object in update. Now it would be lovely if we could just type transform.position.x and change this number directly, but no, boo, you have to change the entire vector in one go. Oh, and this time we're going to have to use vector 3 instead of vector 2 because the transform has 3 numbers. Even though we're making our game in 2D, Unity is still fundamentally a 3D engine, and so it's keeping track of the object's depth with the Z value. So, here's what we'll do. We'll take the current transform.position and then equals. We want to add to its current position, so write transform.position again, and then plus. And finally, in brackets, we'll do vector3.left times move speed. Back in Unity, press play, and whew, that's way too fast. Now you might think that you could just change this move speed variable to a really small number like 0.001, and that will work, but that's not actually the problem here. You see, code in update just runs as often as it can. In fact, if we check the stats in game view, we'll see the game is running at over 1000 frames per second. Sorry, PlayStation 5, 120 FPS? Pfft, that's got nothing on Flappy Bird. And the real problem is that the game may run at different speeds on different computers, and we don't want the pipe to move faster or slower depending on your rig. Real games have actually made this mistake. In Dark Souls 2, weapon durability was once tied to frame rate, so your swords would break twice as fast at 60 FPS compared to 30 FPS. That was a whoopsie. Luckily, it's a pretty easy fix. We just multiply it by time.delta time.
So multiply it by time dot delta time inverted comma, whatever the thing is.
This ensures the multiplication happens the same no matter the frame rate. We didn't need it for the velocity code because physics runs on its own little clock, but otherwise we will need it. If you want to know more about this or anything really, the Unity docs are a good place to check. You'll find info and sample code. Okay, now with that fix in place, our pipe moves smoothly across the screen. Lovely. Next, we want to create a system that will continually spawn new pipes. To start, take the...
Let me just quickly test real quick. Alright, let's see if we have any errors. Come on, hopefully not. Nope, no errors. Great, bro. W game. Oh, crazy. Oh, I forgot that it was space. Oopsies. Oh, damn. I'm just rotating around. Helicopter, helicopter.
A parent game object from the hierarchy and drag it
Oh, wait, I should probably put the pipes in. But we'll deal with that another day.
into your project. The parent game object from the hierarchy and drag it into your project. This creates a prefabricated game object, or prefab. This is like a blueprint for a game object, and we can create new versions of this entire game object with all of its children, components, and properties. Oh, and before we move on, we can delete the original in our hierarchy now. Bye-bye. Let's make a new game object called Pipe Spawner. We'll put it just to the right of the camera, and we'll make a script for it. The purpose of this script is to spawn new versions of
Pipe spawner. Component.
the pipe prefab every few seconds. And because the pipe already has code to move left, the pipe will automatically move across the screen as soon as it spawns in. We're going to write
Oh wait, I forgot to do this. All the way over there.
write some code to spawn that prefab we just made. So we'll start by making a reference to the prefab. Up here, we'll type public game object pipe. Then in Unity, we'll use the same drag and drop method to fill the slot, but this time, instead of a component, we'll drag the
Wait, wrong thing. That.
prefab from the project panel. Now, Unity has a nice built-in method for spawning new game objects. We'll type instantiate, and then open the brackets.
Instantiate. Instant. Oh, brackets.
In here, the command is asking for some extra details. We can actually flip through these to find different, recipes, I guess? Number 4 looks good. It will create an object at a specified position and rotation. So for the game object, we can type pipe. For position, we can just type transform.position to get the position of the
Pipe, comma, and transform dot position, comma,
object holding the script. That will make it spawn on top of the spawner. And for rotation, let's just use transform.rotation.
Transform dot rotation. Comma, or no.
So again, it's the same as the spawner.
And then comma dot.
Let's run it, and oh my god, that's not what we want. Spawning works great, but they're coming out every single frame, and we want them to come out on a nice interval that we can control. So, back to Visual Studio. What we're going to do now is write some code to make a timer. This will count up for a specified number of seconds, run some code, and then start the count again. To do this, we'll need to make a couple variables. A spawn rate is how many seconds
Public float
it should be between spawns.
rate
And then a
equals
timer
public float spawn rate public float spawn rate equals 2 inverted comma
is the number that counts up.
or whatever.
We can
that
make
is.
this one.
I'm not even sure what that is, but yeah. Then private float timer
On private, as we won't be changing it
equals 0 equals 0 that thing.
in the editor or anywhere else. In update,
Ooh, chat. It was good chat.
we'll do another if statement. This time, if
So like, I didn't really mean to, but yeah. So let's get to work. If timer
the timer is less than the spawn rate, then we
if timer less than where's that sign? Oh, there it is. Okay. If timer less than spawn rate, then Alright, there we go.
want to make the timer count up by 1. So we'll take
Spaghettios.
the
So
timer
then,
as it currently is
timer
and add
equals
time.delta time to it.
plus
This creates
time.delta time. Wow. Timer dot time, or no, wait, don't just, okay, wait, timer equals timer plus time dot delta time,
it's a number that counts up every frame and works the same
and then this thing.
no matter what your computer's frame rate is. We can actually shorten this by changing it to plus equals, but don't feel like you need to make your code as short as humanly possible just to avoid getting sniffy YouTube comments. If timer equals timer plus is easier to read and grasp, then that's absolutely fine. You can always swap to the other version in the future when you feel more confident. Now, before I said an if statement is like a gate, and we can add another gate to the side of it with else. This means if the condition isn't met, then skip the code and do the code in else instead. So we'll put the spawn code in here.
Bro, now he's just going way too fast. Like, god damn. Anyways, bro, I messed up. Else, wiggly brackets, nope, 7. Wiggly brackets. Then,
And also reset
oh, he just friggin'.
the timer to 0 in the
Hey,
future
friggin'.
when you feel more confident. Now, before I said an if statement is like a gate, and we can add another gate to the side of it with else. This means if the else instead, right? If it is, then count the timer up. If it's not, right? If it is, it asks if the timer to 0. So then skip the code and do the code in
Okay,
else
let's go.
instead. So we'll put the spawn code in here.
Okay. So spawn code. Just copy that, put it in here, and hippity hoppity, get out of here.
And also reset the timer to 0. So now every frame
Timer equals, okay, so wait. Timer equals 0. Nice.
it asks if the
Oh yeah, I forgot. Coding full stop.
timer is less than the spawn rate. If it is, then count the timer up. If it's not, i.e. the timer has actually met or exceeded the spawn rate, then spawn a pipe.
Wait, what? Mine does not look like that.
And start the timer again. Put this in Unity and pretty good. I'm happy.
Yeah, I'm not sure if this is gonna work. It's not, probably, because, yeah. I didn't do the exact thing he did because I wasn't sure how to. But, yeah, so let me just redo that again real quick. Okay, so else has to be here. I realize that now. Now let's see. I didn't even do much. Yeah, I still have errors. Keep misclicking on my keyboard, but it's kind of hard to type. But was it just the spaces or what? No. So what is it then, bro? What is it? What the Sigma? Chat. What the Sigma? What the Sigma is this chat?
But don't feel like you need to make your code as short as humanly possible just to avoid getting sniffy YouTube comments. If timer equals timer plus is easier to read and grasp, then that's absolutely fine. You can always swap to the other version in the future when you feel more confident. Now, before I said an if statement is like a gate, and we can add another gate to the side of it with else. This means if the condition isn't met, then skip the code and do the code in else instead. So we'll put the spawn code in here. And also reset the timer to 0. So now every frame it asks if the timer is less than the spawn rate. Then skip the code and do the code in else instead. So we'll put the spawn code in here and also reset the timer to 0. So now
I'm confused.
Now, every frame, it asks if the timer is less than the spawn rate. If it is, then count the timer up. If it's not, i.e. the timer has actually met or exceeded the spawn rate, then spawn a pipe and start the timer again. Put this in Unity and pretty good. I'm happy with.
Put this in Unity and kaboom, it doesn't work. Bro, I don't understand. My foot just fell. Bro, did I miss something or what? Like, $23. What are these errors? Expected identifier expected. 832. What? What do you mean 832? I mean line 832? Where even are the lines? It won't even tell me.
That. The only problem is we have to put the spawn code in here and also reset the timer to 0. So now,
Bro, that's literally exactly what I did. Like, it's literally what I did, bro. Just rechecking everything. I did everything the same as he did. Why is this a comma and not an inverted comma? Yup, that was it. Well, we fixed it. Great. Now let's test. Let's see. Are the pipes coming in? Yeah! Let's go, bro. Computer science. We got pipes spawning in now. We got Flappy Bird, bro. Crazy how it took me so long to do this. Yeah. I'm stuck. Help me.
every frame, it asks if the timer is less than the spawn rate. If it is, then count the timer up. If it's not, i.e. the timer has actually met or exceeded the spawn rate, then spawn a pipe and start the timer again. Put this in Unity and pretty good. I'm happy with that. The only problem is we have to wait ages for the first pipe to spawn. It would be good if this came out immediately, right? Now we could copy and paste the spawn code into start, so it happens once in start and then happens over and over in update. But that's a bad idea. You should generally try to avoid having this same or even similar code in multiple places. What happens if we want to change how the spawn works? We'll have to find and change it everywhere. No good. Instead, we can put the spawn code in a new function and just run that function. So here, below update, but above the final curly bracket.
What is this, pipe spawner? Alright. So, okay, bro. Okay. Under here. Bro, underwear! Underwear. Made you say underwear. Void.
We'll make a function called void spawn pipe, and then cut and paste the instantiate.
Bro, calm down with the speed. God damn.
Final curly bracket. We'll make a function called void spawn pipe.
Void spawn pipe. And then
cut and paste.
And then cut and paste, and then do this, and then do that, and then do this, and then do that, and then boom, you have a fully working FPS shooter. Yes, bro. Very, very complete beginner friendly code. Yes. Very.
Paste the instantiate code into there.
Okay. Instantiate. Delete that. Put that there. Save. Look.
Now we can just write spawn pipe with empty brackets in both update and.
Now above timer, I'll write spawn pipe brackets go dot
start. This will run all the code in that.
also up here.
Function when these lines are executed. And with that done, it will make a pipe as soon as the game begins, and will make...
Alright, let's see. Okay. Calm down, boy. You gotta calm down, boy. It didn't actually. Well, it kinda did, but like my screen is very long for some reason. I don't know, bro. If I make this bigger, will the screen just becomes... Alright, thank you, Mr. Tutorial Man. Very cool.
new pipes every time the timer maxes out. Perfect.
Also, by the way, I don't like this thing there. I'm dragging it up here. Now the game's here. Now let's test. Dun, 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 dun. Yeah, it doesn't really spawn them automatically. No, it does not. No, no. No, it does not. No, it does not. No, no, it does not. No, little boy. Little boy. But yeah, it doesn't work. But now let's see.
However, this is a pretty boring game, right? The pipes always come out in the middle. We want them to come out at random heights. So remember that when we wrote the instantiate code, we had to pick a position for the object to appear? We'll change that value. Right now, the pipes always spawn on the same position as the spawner. We want the x value to be the same, but for y, we want to pick a random point somewhere above or below the spawner. So let's create a public variable for a height offset.
Under that, public float height of...
Maybe
height.
10.
Oh no, that's height offset. Okay. Public float height offset. That's not right. Offset. Offset equals 10.
And then we'll make a float.
And that, I keep forgetting to put that down.
Called lowest point. Because we're making this variable inside the function rather than at the top of the script, it means it can only be used
Put there. Float lowest point.
within the function. But it also means we can set it by doing a calculation. So we'll do equals transform.position.y minus...
So float lowest point equals transform dot position dot 1
minus height offset.
no dot y minus
And then we'll
height
make another
offset. And then make another float.
one for highest point, but this time it's plus.
Get float highest point.
Height offset. That gets...
Bro, calm down. Ah. So 25, 34.
plus height offset.
Okay, so transform dot position dot y plus height offset, then dot.
Set.
Yeah.
That gets us these two numbers. Then we'll replace the transform.position in our instantiate code. We're going to write new vector 3. We have to write that when
New vector 3.
whenever we're specifying our own numbers for a vector. And then in brackets, we'll specify the x, y, and z values as 3 different floats. For x, we want this to be the same as the spawner, so we'll do transform.position.
Transform dot position dot x.
.x. But for y, we can do random.range.
And then random dot range.
In the brackets for that, we can supply a minimum and maximum point to pick from. That's lowest point and highest. Point. Then a 0 for z, and close the brackets.
So highest point.
Back in Unity,
Oh, come on. I keep getting these freaking errors about these signs, dude. They're annoying. Correct. It literally says no issues found. Why would it say that if there's literally an issue? It's kind of stupid. Bro, I don't want to keep going back into the script and doing that, changing this, because it doesn't work. That is very bad.
from. That's lowest point and highest point. Then a 0 for z, and close the brackets.
And look. Shit. Okay, let me see if I have that. Well, how did I not? Yeah, I need to stop rushing it, maybe. Damn. Still 2 more. There still is 2 more.
Back in Unity,
Bro!
and then in
My
brackets,
God,
we'll specify the X, Y, and Z. Then we'll replace
oh, oopsies. Why is that a question mark? Plus. Yeah, plus. I am Steve. Okay, come on, come on, come on, come on. Yes, that fixed both of them. Great. Great, 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 great. Now let's see. Now let's test. Now let's test. Alright, stop falling, little bro. Stop falling, little bird. Wait for the pipes to come in. Alright. Now. Now. Perfect. They're like doing its thing. They are falling. Not that good at it, I see. Considering, yeah, Unity, that's actually pretty questionable what they've done there.
the transformed opposition in our instantiate code. We're going to write new vector 3. We have to write that whenever we're start to spill out the side of back in Unity. Nice! The pipes will spawn anywhere between these 2 numbers. Oh, one last thing. Every time these pipes spawn, they'll appear and move left forever, which isn't great practice. They're off screen and doing absolutely nothing, and yet they're still in memory and running code every frame. And if too many spawn, they'll start to spill out the side of your monitor and make a right mess on your desk. So let's fix that. Now we could make a timer and delete the pipe after a few seconds. But instead, we'll check the X position of the pipe and delete it if it goes past a certain point. We'll borrow the bird to find out the X coordinate of the left of the screen. Looks about -45. In the pipe move script, we'll add a float for a dead zone, -45. X position of the pipe and delete it if it goes past a certain point. We'll borrow the bird to find out the X coordinate of the left of the screen. Looks about -45.
Okay, let's say -45.
In the pipe move script,
The pipe move script, huh? Haven't heard that one in a while.
we'll add a float for a dead zone, -.
Yeah, but
45, and then a simple if statement. If transform.position.x is less than dead zone, then destroy the game object that holds this script. Run it in Unity and bam, they're dead.
One billion errors spawn in. Oh, what a surprising shock. It's probably because I didn't go that fast this time. Yeah, I need to go way slower when typing code in, especially since I'm new to it. But like, yeah, I've been rushing it, and then I do something wrong, and it takes me like 2 times longer than it would have normally taken. Ooh, so wait, I just want to see. The bird's gone, also. Oh, the pipes, they're like spawning in really good. Really delayed and stuff. Come on, birdie, birdie, come on. Okay, but, let's see. Yes, okay. Despawning. Great. Awesome sauce.
Let's do one more thing, just as a teachable moment. Just before the destroy line, let's write debug.log and then in brackets, pipe deleted. Then back in Unity, you'll see one other panel I skipped during the UI demo. It's a tab next to project called console. Then when we run the game, every time a pipe is deleted, our message is sent to the console. This is a wonderfully useful way to debug our code because we can find out exactly what the code is up to. Recap time. Game objects can be turned into Okay, our next step is to keep track of the player's score and show it to the player on the user interface. Then we want the score to go up by 1 every time the bird goes through the pipes. So remember that a game object doesn't have to be a physical thing in your game world like a character or an enemy. It can be a completely invisible manager that's just keeping track of critical data like health or time or score. And then we can make that information visible to the player using a user interface. So let's start by making the UI. Like everything else, it's a game object in the hierarchy. This time go down to UI and pick text, which may be under legacy.
Sorry, UI legacy text. Okay.
We'll need to zoom really far out on the scene view to actually see the UI. To make sure the UI looks the same on every device, we'll pick this new canvas game object and set the canvas scalar component's UI scale to scale with screen size, and choose a sensible reference resolution. I'm going to use 1080p again. We can then move our text around. You'll notice that UI has a rect transform rather than a normal transform. The most important thing to note is that you don't really want to mess with the scale of elements, instead change the width and height. I'll then increase the font size and set the default text to 0, and then check it. It all looks nice on the game. game view. Okay, now we want to make a script that will store the player's score and change the number on the UI to that score. We'll make a game object called Logic Manager, and we'll give it a script. This script is going to keep track of high-level information.
Alright, so why is this so tiny? I just realized. Logic Manager.
Information like the player's score, and it will have various meta-level functions that we can run. So we'll delete start and update. We don't need them in this script. We can always add them back later if we change our mind. So we'll delete start and update. We don't need them in this script. We can always add them back of high-level information like the player's score, and it will have various meta-level functions that we can run. So we'll delete start and update. We don't need them in this script. We can always add them back later if we change our mind. We want to store a number for the player's score. This time we don't want a float because we only ever want
public int player score.
round numbers. So let's do an int instead. That's an integer, no decimal places. And because we want to update the UI text we just made, we will, as always, have to make a reference to it. Except text doesn't seem to be a thing. Well, by default, a script only loads in stuff you need for basic Unity functionality. But if we go up to the top and type using unityengine.ui, we can now access more functionality, in this case UI stuff. Now we can make a reference to text. we'll need to drag the text component into this field back in Unity. Because we're referencing a component on another game object, the text on the UI, the best way to do this is to just drag the whole game object into our slot. This will automatically find the text component for us. Handy. So now we want to make a function, and we'll call it add.
Bro, I love this. It's so fun. I love making games. Add score. It says I love making games. 2 minutes later, 10 billion errors. I hate making games. I'm just kidding though.
Add
It's
score.
pretty fun when you
And
do it
because
right. Toom, boom, toom, 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 sahoo.
we're going to run this function from other scripts, we'll set it to public void. This function needs
Ooh, public void. Ooh, cool.
to do two things. Add 1 to the player's score. Easy enough, we know how to do that now.
Player score equals player score plus 1.
And change the text on the UI to be this number. Oh, the text box is looking for a string, a sequence of characters. And our score is an integer. They look identical to us humans, but robots are fussy. Easily fixed, mind you, by adding .toString to the game score. To make sure this works, let's give ourselves the power to run this function from Unity itself. All we need to do is write context menu and a name above the function.
Just come here, enter, and then, okay, this time we're using that thing. Context menu, comma, that in whatever he's gonna write, increase score.
Now in Unity, while the game is running, hit the little dots on this script and pick the function. Nice. This sort of thing comes in real.
Come on. Bro, my headphone just died, one of them.
Handy for test.
The left one died. Damn. Okay. Let's try to see how to fix this.
Above the function. Now in Unity, while the Unity itself. All we need to do is write context.
Yeah. I'm gonna go charge my left headphone while I still use this one. Alright. So, plug it in. There we go. Because it needs to be charged. So that's kind of bad and sad. So yes, that's correct. Correct.
Menu and a name above the function.
Text of score.
Now in Unity, while the game above the function.
Oh my. Oh, bro. Bro. One typo and your whole game's over. Mine isn't. I didn't give up. But, yeah, you're pretty cooked. You're pretty cooked, bud, bro. Crazy. Bro, should I sell this game on Steam for $1 million? I might do that, to be honest.
Now in Unity, while the game is running, hit the little dots on this script and pick the function. Nice. This sort of thing comes in real handy for testing. Okay, so now that we know the function runs, we specifically want to run it when the bird goes between the pipes. And the way to do this is collisions. Now, if two objects have colliders, they will bash into each other. In fact, in our game, the bird will already crash into the pipes because we've added colliders to both. However, you can also have invisible colliders, called triggers. They don't create an actual collision, but they do let you know that two objects have touched, and you can run code at that moment. So we're going to put a trigger in between the pipes, so we know that the bird has passed through them, and then at that moment, we'll run add score.
Okay, before that, though. Just fix the colliders on these things, bro. Cause like, god damn, this pipe is messed up. Look at that, I'm not spinning around anymore. Okay, great. These pipes finally work better. They're just really easy. I'm gonna make it harder later, trust. For now, you know, testing purposes, aka I suck at that. But yeah.
Let's open up the pre.
Okay, we're 32 minutes in. We might be able to do this before I gotta go to sleep, but
prefab for the pipes.
I mean, it is almost 1, so like, I don't know if we can.
We'll make another game object called middle, and we've added colliders to both. However, you can also have invisible colliders called triggers. They don't create an actual collision, but they do let you know that two objects have touched, and you can run code at that moment. So we're going to put a trigger in between the pipes, so we know that the bird has passed through them, and then at that moment, we'll run add score. Let's open up the prefab for the pipes. We'll make another game object called middle, and it needs a box collider. Let's make it this sort of shape.
Middle, and then you said box collider 2D.
And this time we'll tick the box, is trigger. Finally, let's add a script to this new middle game object.
Pipe
Beneath
middle script.
update, type on beneath update, type on trig, and the autocorrect will help us type out on trigger enter 2D. Just press tab to autofill. Anything in this function trig, and the autocorrect will help us type
Bro, I don't have autocorrect. Microsoft Visual Studio. Yes. Bro, it doesn't work. Oh my. But does loading mean there's nothing there? If there's nothing there, just say so. the chat. Let's wait for this. Alright guys, I'm gonna go now. I worked